All right, let's talk about something that you might not find in your pharmacology textbook, but is becoming absolutely critical in the world of healthcare. In today's pharmacy, everything is connected. And knowing how those connections work, well, that's no longer just for the IT folks. It's quickly becoming a core skill for pharmacists like you.
So picture this. It's a crazy busy Monday morning. The queue is growing, and suddenly the prescription system just stops. The screen flashes that dreaded message, cannot connect to the network. All your critical patient data is locked away. This isn't just a tech headache, right? This is a real problem that directly impacts patient care. And believe me, this is the exact moment where a little bit of network knowledge can make you an absolute hero.
So, to solve this digital mystery, we have to start with the very first clue, the network address. Think about it. Every single device in your pharmacy, from the computer you're using to the little printer that spits out the labels, has to have one. It's how they find and talk to each other. And that brings us to the star of the show, the IP address. IP stands for Internet Protocol. The easiest way to wrap your head around it is to think of it like a street address for your house or a phone number for your phone. It's a totally unique number that tells everyone else on the network exactly where to send information, like a new prescription, and where to get information from. Without an IP address, your computer is basically on a deserted island. But here's the cool part. An IP address isn't just a random string of numbers. It actually has two parts that work together. The first part is the network ID. You can think of this as the name of the street your pharmacy is on. It tells everybody, hey, this device belongs to the Main Street Pharmacy Network. The second part is the host ID, and that's like the specific house number on that street. It points to your specific computer or the server or the printer. Now, you've probably also heard people talk about a MAC address, and it can get a little confusing, so let's clear it up. A MAC address is permanent. It's burned into the device's hardware, kind of like a serial number on a car. It never changes. An IP address, on the other hand, is more like your hotel room number. It's assigned to your device when you connect to a network, but if you take your laptop to a different network, you'll get a new one. So the MAC address tells you what a device is, and the IP address tells you where it is right now. Okay, so all the devices in your pharmacy have an address, and they're all on the same street. But how do they know the boundaries of that street? How does your computer know that the label printer is a local neighbor it can talk to directly? Well, that's where the subnet mask comes in. This is another special number that basically draws the property lines for your local network. It works hand in hand with the IP address to tell your computer, look, anyone with an address that starts like this is in our neighborhood. You can chat with them directly. But anyone else, they're outside the neighborhood, and you're going to need to take a different route to reach them. And that brings us to the next logical question, right? What happens when your computer needs to get information from outside its local neighborhood, like, say, connecting to a national drug database or an insurance company's website? It uses what's called the default gateway. The easiest way to picture this is to think of your pharmacy's router as the one and only exit door for the entire building. The default gateway is simply the IP address of that door. Anytime your computer needs to send a message to the great big world of the internet, it sends it straight to the gateway, and the router handles it from there. Okay, theory time is over. We now have our three main clues: the IP address, the subnet mask, and the default gateway. With just this information, we can go from being confused to being prepared. We can build our own troubleshooting toolkit to solve that network crisis we talked about. And your toolkit has two super powerful but really simple tools. First is ipconfig. Just typing that into a command prompt is like pulling out your ID card. It immediately shows you your current IP address, your subnet mask, and your default gateway. Your address, your neighborhood, and your exit door. The second tool is ping. Ping is basically the network equivalent of yelling Marco and waiting to hear Polo back. You send a tiny signal to another address, and if you get a reply, you know you have a live connection. So when things go wrong, how do you use these tools? You follow this dead simple three-step check. Step 1, check yourself. Run ipconfig and just make sure your computer has an address in the first place. Step 2, check your local connection. Ping your default gateway. If that works, you know your connection inside the pharmacy is fine. And step 3, check your external connection. Ping an address you know is always up, like Google's server at 8888. See the logic? If step 2 works but step 3 fails, you've just proven the problem isn't in your pharmacy, it's the internet connection itself. And just like that, you've gone from panic to problem solver. You now have a clear path to figure out what's wrong. So let's put all these pieces together, add one final piece to the puzzle, and see the whole picture. Here's the whole shebang. You've got your IP address, that's your unique ID. You've got the subnet mask, which defines your local neighborhood. And you've got the default gateway, which is your door to the outside world. But there's one last helper we need to mention, DNS. That stands for Domain Name System. Just think of it as the network's address book. It's the system that translates a name you can remember, like google.com, into the IP address that computers actually understand. Which brings us all the way back to the beginning. As pharmacies rely more and more on e-prescribing, connected patient records, and all sorts of digital tools, being able to run a simple check like this, it's more than just a tech skill. It's about ensuring you can continue to care for your patients. It's about safety. So I'll leave you with this to think about. In our world of connected care, is this kind of network literacy becoming a modern pharmacist's new superpower? Thanks so much for joining me.